All right, in this video of applied animal feeding, we're going to do our second substitution problem. And this one is going to be a problem that has a fixed ingredient or something that's set in the ration from the beginning that we need to account for. So the scenario that we're dealing with, there was a picture of it beforehand, and there should be a picture in the upper corner here somewhere throughout the video. But we've got a lamb feedlot in Nevada that has access to Sudan grass hay pellets, flaked sorghum for an energy source, corn gluten meal for a protein source, dicalcium phosphate for phosphorus, and limestone for calcium. The caveat and what makes this difference from the previous video that had a dairy heifer example is that ammonium chloride is fixed at 0.5% of the ration dry matter. So we're going to have to figure out how we handle that. So as usual, the first step I do is I gather my information and I make my chart. I've pulled in all of the requirements. 4.1 pounds of dry matter is what each lamb is eating. They require 1,500 kcals of net energy for gain. So you may have to do some converting from Mcals to kcals to be able to get to that data. They require 0.67 pounds of protein, 0.01 pounds of phosphorus, and 0.02 pounds of calcium. I pulled in all of the feeds, and we have our roughage source, the Sudan grass, energy source is the sorghum, protein is the corn gluten meal, phosphorus is the dicalcium phosphate, calcium is limestone, and we have this fixed ingredient, ammonium chloride. Now we need to look at all of its information too, because lo and behold, it actually supplies quite a bit of nitrogen or protein to these animals. So it does have an impact and it takes up space in the ration. So it's kind of like the algebra problems where we had to account for fixed ingredients. The same goes for these problems. Now, one note, if you're, whatever library you're using, if it has Mcals per hundredweight of net energy for gain, to get to kcals per pound, all you do is add a 0. But it's going to depend on what your reference information has. But I'll give everybody a moment, pause the video, copy down the data so that you can work alongside of me on this problem. All right, the first thing we need to do is check the forage only. And in this case, plus the fixed ingredients, because they're already set. We know what they are. So for this problem, we have Sudan grass and we have the ammonium chloride. The first problem that we need to do is figure out how much ammonium chloride. Right? Oops, my camera shifted on me. How much ammonium chloride? Camera does that. The first thing we need to do is figure out how much ammonium chloride. So we know that these lambs are eating 4.1 pounds of dry matter. Great. We know that ammonium chloride, if we go back to our example, is fixed at 0.5% of the ration. So if we multiply that times the decimal form of this number, .005, we will find out that we need, oops, I got to put another 0 in there, 0.02 pounds of ammonium chloride. So now that we know how much ammonium chloride we have, we can figure out how much we have total. So we're going to be figuring out the amounts for dry matter, NEg, protein, phosphorus, and calcium. We know that we just determined that 0.02 pounds is going to be ammonium chloride out of that 4.1 pounds. So the remaining amount is that Sudan hay, which is going to be 4.08. So now, using our feed information, we're going to take the amount times the appropriate concentrations and multiply them across to get how many kcals, pounds of these nutrients we have. So I'm going to go ahead and do that right now. Okay, so now I've taken the amount of the feed times each nutrient concentration, and I have determined how much nutrient we've got supplied to all of these. So the next step is to take the supply minus the requirement, and we're going to compare that back to these original requirements and determine if we have a deficiency or an excess. So these values here in the requirement row are what I'm referring back to. So we know that our dry matter needs are being met. If we take the 1020 minus 1500, we'll find out that we're short 480 kcals. So we have an energy deficiency. 0.4 minus 0.67 tells us we're deficient 0.27 pounds of protein. 0.009 minus 0.01. We're short just a little bit, but still significant on the phosphorus. And we're actually good on calcium right now. So if we figure out how big of an issue is this energy issue, what percent magnitude is it? If we set it up to figure out what percent it is of the requirement, that's a 32% deficiency. That's big. So we have to fix protein. Fix energy. So what we're going to do is we're going to take our energy feed, the flake sorghum and its concentration, and find out the difference per pound between these two. Now, the beauty of using calories, this is already expressed kcals per pound. So it's simply the difference of these two numbers. So it's the 690 minus 250. And so this is coming from the sorghum, and this is the Sudan grass. And what we learn is, it's clear, 690 minus 250 equals 440. So for each pound for pound substitution from flaked sorghum and Sudan grass, 1-for-1 substitution, we gain 440 kcals. That's our net gain. And that's our new concentration. So if we take our deficiency of 480 kcals and divide it by our concentration, which happens to be kcals per pound, kcals will cancel And we're left with 1.09 pounds of sorghum. Okay, so now we have fixed energy. Let's check it. So we know that we will have the sedan, the sorghum that we just figured out, and the ammonium chloride. And we're going to be checking dry matter, net energy for gain, protein, phosphorus, and calcium, just like before. There is definitely a repetitious part of this. 4.1, but we know they have to add up to that. We have 0.02, no NEg, but it does offer 0.03 pounds of protein. So the fixed ingredient just carries across like it did before. Sorghum is now fixed at 1.09 pounds. So we just need to figure out what the sedan grass is. So 4.1 minus 1.09 minus 0.02 gives us 2.99 pounds of sorghum. So again, I'm going to take the amount times the nutrient concentrations for each one and figure out exactly what we've got. Right, now that we have all of those calculated, time to check our supply minus the requirement. We're good there. This rounds up to 1,500. We're good on energy, which was good because that's what we just solved for. If we take the 0.42 pounds of protein supplied minus 0.67, we are still deficient 0.25, and that divided by the to create a percent deficiency, that's a 37% deficiency. So we definitely have to address that. 0.010 minus 0.01, we have met the needs there. And 0.01. We are short a little bit of calcium. And so we might have to address that finishing up this problem. But what we see here is now it's time to fix protein. We've got the energy dialed in. We're good there. So now we fix protein. So the net gain is going to be the difference between the sedan grass and the protein supplement in a pound for pound. So in 1 pound of corn gluten meal, we have 0.46 pounds of protein. In 1 pound of sedan grass, we have 0.09 pounds. That difference is 0.37. So to fix the protein, we take our deficient amount divided by the concentration. So we need about 0.68 pounds of corn gluten meal to fix that problem. Great. Let's double check it. I'm hoping if you stayed through these other videos with me, you've now seen us do the same step basically over and over again. So now we're going to check it. We're going to check the dry matter, the net energy for gain, the protein, phosphorus, and calcium. But now we have a couple fixed ingredients. We have the sedan grass hay, which is an unknown still. We have the sorghum, which just transfers straight over 1.09, 752.1. And it really didn't supply any calcium because there's not enough of it. And now we have the corn gluten meal, which is fixed at 0.68 pounds. And we still have our good friend ammonium chloride at 0.02 pounds. And that did not supply any, but it did supply protein, no phosphorus, and no calcium. All right, so I'm going to go through and determine the new amount of Sudan grass and the new amounts of each of these feeds. All right, now we can compare our supply minus the requirement. And remember, we're going back to this requirement right here. So we know that dry matter is met. We needed 1,500 kcal. Oh, look, we're over it now because that corn gluten meal actually has a lot of energy in it as well. We needed 0.67 pounds of protein. We've got it. We're actually in an excess for phosphorus and a little bit of excess for calcium. So this ration is resolved right here. We don't need any of the mineral supplements, the dicalcium or limestone, because we're adequate and actually a little excess for both of our minerals. So now the final step is to convert to as fed. So those lambs will really be eating about 4.73 pounds or almost 5 pounds as fed per day to meet their growing requirements in this lamb feedlot. And that's how you handle a substitution problem with a fixed ingredient. Just remember that sometimes there may be 2 fixed ingredients, and so you would have to include them from the beginning. Thank you.